Okay. Hi all, and welcome. We have 3.5 today, derivatives of inverse trig functions. So before we begin, I'd just like to refresh you on inverse trig functions and properties. So let's look at number 1. So we're dealing with the inverse sine function. Remember that the inverse sine lives on these restrictions, negative pi over 2 to pi over 2. We use those restrictions when simplifying trig expressions, especially the inverse sine expression. So using that, let's go ahead and just evaluate the given functions. So we'll start with this one. Okay, so to solve this one, we let theta equal the inverse sine of negative 1/2. Then we compose both sides with the sine function. So then sine theta equals negative 1/2, but we have to make sure that the value for theta is on these restrictions. Negative pi over 2 to pi over 2. Now, remember, again, I just said it, the inverse sine function lives right here between negative pi over 2 and pi over 2. So pi over 6, pi over 4, pi over 3, and then same thing down here, negative pi over 6, negative pi over 4, negative pi over 3. Okay, so coming back to the problem, we have to look at, on these intervals of negative pi over 2 to pi over 2, which value of theta gives me negative 1/2. Well, if you remember your unit circle, which you all do, right? Theta, the value for theta is going to be negative pi over 6. That's it. That's all we're looking for. Okay, let me erase that. Gun. Write that down for your reference. That's why you can stop the video. Boom. Okay. All right. Now handling this one, we want the tangent of inverse sine of 1/3. So what we do here is, again, we let theta equal the inverse sine of 1/3. Then sine theta equals 1/3 on negative pi over 2 to pi over 2. Okay, so there's no radian value of theta that covers 1/3, not that we know of. So to solve this one, remember, we make a right triangle. And based on the value of sine, if it's positive, then we must be in quadrant 1. And if sine is 1/3, that means the height is 1, the hypotenuse is 3, and by Pythagorean theorem, the base is 2 square root 2. And there's my value of theta. Okay, with that being said, since we made a substitution, since all of this inverse sine is now theta, all of that's now theta, right? This whole thing becomes the tangent of theta And now all we want to know, since theta contains all this information in the triangle in the quadrant, all we want to know is what is the tangent of that theta. So tangent of that theta is going to be opposite over adjacent. Rationalize, and we get square root 2 over 4. And that's it. Okay, so that is your trig refresher. Bring back some memories? I hope so. Okay. And down below, just a refresher. Oh no, oops. A refresher on inverse cancellation equations. Remember, inverse sine composed with sine. So inverse sine composed with sine cancels and has to obey the restrictions of negative pi over 2 to pi over 2. Sine composed with the inverse cancels and has to obey the restrictions of negative 1 to 1. I think I put those there to help you with your homework. But it's also good to remember and refresh. Okay. Now we want the derivative of the inverse sine function, and we're going to prove that derivative by the use of right triangles in the unit circle. Since sine is continuous and its inverse is continuous, this means sine has a derivative and the inverse has a derivative. And we calculate the inverse by implicit differentiation. All right. Okay. All right. So up there, you already see the derivative for the inverse sine function. D over dx of the inverse sine of x is 1 over the square root of 1 minus x squared. The chain rule derivative, d over dx of the inverse sine of u, is u prime over the square root of 1 minus u squared. That's the chain rule derivative. Okay. So now we want to prove the derivative of the inverse sine function. So I'll work all through these rules. So, all right, step 1 says let's have y equals, oh goodness, behave pin. Y equals the inverse sine of x. 2, just like the above examples, we compose both sides with the sine function. So now I get sine y equals x. Of course, on the restrictions negative pi over 2 to pi over 2. Okay. 3, draw a triangle. That's not a triangle. There we go. 3. So we're going to draw a triangle. So I'm going to rewrite this as sine of y equals x over 1. Which means now, on my triangle, on those given restrictions, if sine of angle y is positive, then again, we must be in quadrant 1. Here's my angle of y. If sine is x over 1, sine puts opposite over hypotenuse. And then, by Pythagorean theorem, the base should become 1 minus x squared. Okay. And then it says to solve for cosine y. So the reason we're doing this is when we take the derivative, you're going to get a cosine in there. And if we already have cosine's value, then we're good to go. So that's the only reason we're doing this now. You can do it now, you can do it later, does not matter. So if I say cosine of y, that puts the adjacent side of 1 minus x squared over the hypotenuse of 1, but that's just the square root of 1 minus x squared. Okay, so this is that save for later, okay? Okay, now we come to step 4. Take the implicit derivative, so step 4. Take the implicit derivative of x equal to the sine of y. Okay, well, the left side becomes 1. The right side, we chain rule with implicit. So first, derivative of the outside, cosine y, times derivative, implicit derivative of the inside, y prime. Now, solve for y prime, divide by cosine y, I get 1 over cosine y equals y prime. And now, here's where we make that connection. What is cosine y equal to? There we go. So cosine y is the square root of 1 minus x squared. Therefore, we get 1 over the square root of 1 minus x squared equal to y prime. Therefore, proving that d over dx of the inverse sine of x is equal to 1 over the square root of 1 minus x squared. That's it. That's it. That is a proof by triangles. A proof of the inverse derivative by triangles, unit circle, restrictions. Yeehaw. You don't have to know how to prove it, but it's always nice to know. I gave you the formula above, so you can just use that. Yeehaw. Okay. And just like sine, we want to prove the derivative of the inverse cosine. And the inverse cosine lives on these restrictions, 0 to pi. So that's where the inverse cosine lives, from 0 to pi. Okay, so with that being said, I don't need that. There we go. Let's go ahead and prove the derivative of the inverse cosine function. You see it there listed. It says the inverse cosine is, the derivative of the inverse cosine is -1 over the square root of 1 minus x squared. And the chain rule derivative for the inverse cosine is -u prime over the square root of 1 minus u squared. So, same exact steps. Let's go ahead and solve this again, or prove this. So, step 1, y equals the inverse cosine of x. Step 2, compose. Cosine y equals x on 0 to pi. Step 3, draw your triangle. Of course, I'm going to rewrite this. Rewrite this as cosine y equals x over 1. Now, when I draw my triangle, if cosine is positive, then of course we must be in quadrant 1. Here's y. And cosine is adjacent over hypotenuse. So here's x, here's 1. And by Pythagorean theorem, the height is going to be 1 minus x squared. Okay. And now for this one, we say solve for the sine of y. Again, it comes in later. You do it now or you do it later, does not matter. So cosine y is equal to, not cosine, sine. Sorry. Sine y is equal to opposite 1 minus x squared over hypotenuse. But again, that's just 1 minus x squared. So again, save for later. Okay, 4, derivative time. 4, d over dx of x equal to d over dx of the cosine of y. We get 1 equal to chain rule, implicit derivative. So derivative of cosine, negative sine y, times the implicit derivative of the inside, y prime. Divide by sine, negative 1 over sine y equals y prime. And again, what is the value of sine of y? And that's what we plug in place. Negative 1 over the square root of 1 minus x squared equals y prime. Therefore, proving the derivative of the inverse cosine of x is negative 1 over the square root of 1 minus x squared. Ching. Beautiful. See, not too hard of proofs. But again, you don't have to know how to prove them. Just be happy that you learned it. Yeah. Okay. I think one of the reasons I'm excited is this is my last video lecture for the day. God, third one. 3 in a row. Then I get to relax. Okay. Here is the table of trig inverse derivatives. So this is what we will be referencing when working the rest of these practice problems out. All of these lovely practice problems out. Okay, I'll even be referencing it. But that's a lot to look at. But there's the inverse trig derivatives of all 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. All right, so let me pause for a second. Okay, back. Okay, all right. So here we go. Start off with number 1. Differentiate the following equations. Okay, so here you have x times the inverse tangent of x, which means that this is going to use product rule. So f will be x, g will be the inverse tangent of x to the 1/2. I just changed that square root already. F prime is going to be 1. G prime is going to use the chain rule derivative for tangent, which is right above us. That's nice, right? That's the chain rule derivative for tangent. So this means we're going to do the derivative of the inside, u prime, so the derivative of x to the 1/2, we're going to have 1/2 x to the negative 1/2 over 1 plus the inside, x to the 1/2 squared. Okay, so let's clean this up a bit. And this means that g prime becomes 1 over 2 square root x times 1 plus x. Okay, now we're ready to follow the rest of our product rule. So f prime g, I'll write that over here. So we get, let me do that. We get f prime of x equal to inverse tangent of the square root of x plus g prime f. So that's going to become x over 2 square root x 1 plus x. Just make sure I have that right. X over 1 over 2 square root of x times 1 plus x, which means now you can actually simplify this x and that. That's x over x to the 1/2, which that should be just x to the 1/2. So my final answer is f prime of x equals the inverse tangent of the square root of x plus the square root of x over 2 times 1 plus x in all its glory. There you go. Okay. Next. Again, inverse tangent of x squared. This one is just going to use the chain rule derivative for tangent above us. So this means that y prime is going to equal the derivative of the inside function, 2x over 1 plus the inside function squared. This gives me 2x over 1 plus x to the 4th. Done. Nothing else we could do there. Okay. All right. That one's nice. Tangent's probably the nicest. Okay. So now this is going to be 3, a chain rule derivative for the inverse tangent function. Let me just write the inverse tangent derivative over here. I'll write it over here somewhere. Let me see. Is 1 over 1 plus x squared. Okay, cool. So on this next one, it's going to be, of course, chain rule times the derivative of the inside. So for number 3, y prime equals 2 times the inverse tangent of x. That's the derivative of the outside. Now we multiply it by the derivative of the inside. The derivative of the inverse tangent function, 1 over 1 plus x squared. 1 over 1 plus x squared. Okay, clean it up, make it look pretty. The most we can do is make this y prime equals 2 inverse tangent of x over 1 plus x squared. That's it. All right, not bad. Okay. 4. This is going to be product rule, right? This is product rule. There's f, there's g. There's f, there's g. Okay. So setting it up, f is parentheses x squared minus 1 to the 1/2. G is the inverse secant of x. F is going to use chain rule. F prime 1/2 times x squared minus 1 to the negative 1/2 times the derivative of the inside, 2x. Let's clean that up some more. This times that. F prime is going to be equal to x times x squared minus 1 to the negative 1/2. Okay, I'm not going to flip anything over just yet, just for simplification purposes. Well, we could flip it, but I'm going to leave it alone for now. Okay, now we want the derivative of the inverse secant function. So I'll just scroll up. Derivative of the inverse secant function right there. 1 over x times the square root of x squared minus 1. So 1 over x times the square root of x squared minus 1. Excuse me. So g prime becomes 1 over x times the square root of x squared minus 1. All right. So put it together. Let's see. I have a lot of room. Okay. So f prime g, we get g prime of x equals x secant inverse of x times x squared minus 1 to the negative 1 half. Plus product rule, g prime times f. So this ends up becoming x squared minus 1 to the 1 half over x square root x squared minus 1. Okay, make it look pretty time. And on the left side, I can now flip that down. So we get g prime of x equal to x secant inverse of x over the square root of x squared minus 1. Plus, this and this are the same. So guess what? Cancel. Which means that leaves me with just 1 over x. Done. All right. Cool. Combine those if you want. You don't have to. Beautiful. Okay. Chain rule on the next one. Or inverse sine. So let's go look at that. We are going to be using that one. So inverse sine of u prime over the square root of 1 minus u squared. Okay. With that being said, take the derivative, y prime, derivative of the inside, 2x plus 1, 2, over the square root of 1 minus 2x plus 1 squared. So u prime over 1 minus u squared. Let me make sure I have that right. U prime over the square root of 1 minus u squared. Now the question is, can we simplify more? Yes. Let's try it out. So we're going to have to expand that down below. So you get the square root of 1 minus 2x plus 1 times 2x plus 1 equal to 2 over the square root of 1 minus 4x squared plus 4x plus 1, okay, equal to 2 over the square root of 1 minus 4x squared minus 4x minus 1 equal to 2 over the square root of negative 4x squared minus 4x. Okay, now the only thing I see, yes, there's a common factor of negative 4x, but can I take the square root of negative 4? No, unless I want imaginary numbers. So the only thing I'm going to factor out of this is just the 4. That's it, just the 4. So I'm going to make this 2 over the square root of 4 times negative x squared minus x. And now I get y prime equals 2 over 2 square root negative x squared minus x. Cancel. We get just 1 over the square root of negative x squared minus x. That is good practice. Not sure you have to do it. I wonder if WebAssign just takes that as an answer. If it doesn't, then yes, you must do all of this. Okay? But I'd say do it. It's good practice for your algebra skills, which you all are lovely at. Okay? All right. Next. Okay, so 6. Y equals the inverse tangent of x minus the square root of 1 plus x squared. Gross. This is going to be the chain rule derivative for the inverse tangent function. So here we go. I get y prime equal to the derivative of the inside function, right? So that derivative, well, first let me rewrite it as x times 1 plus x squared to the 1/2. So that derivative would be 1 minus 1/2 times 1 plus x squared to the negative 1/2. Right? Because we have to chain rule this part now. So 1 minus 1/2 times 1 plus x squared to the negative 1/2 times the derivative of the inside, 2x. So this is the chain rule derivative for the inverse tangent. All of this belongs in the numerator. That is your u prime. Okay. And then it's all going to be over 1 plus the inside, x minus square root 1 plus x squared squared. Oh boy. Okay, cleanup time. This 2x, that 1/2. We get 1 minus x times 1 plus x squared to the negative 1/2 over 1 plus, let's see, yep, we're going to FOIL this out, children. It's not going to be fun. Or maybe it will, depending who you are. Square root 1 plus x squared, x minus square root 1 plus x squared. And then, still going, y prime equals 1 minus x times 1 plus x squared to the negative 1/2 all over 1 plus, if I FOIL this out, I get x squared minus x minus x minus 2x square root 1 plus x squared plus 1 plus x squared. Now, simplifying this may not do anything for us, but I'm at least trying to make it prettier. Okay, so I have 1 minus x times 1 plus x squared. My goodness. 1 plus x squared to the negative 1/2 all over that one, that makes 2. This one, that makes 2. Plus 2x, not 2x, plus, yes, 2x, plus 2x squared minus 2x times the square root of 1 plus x squared. Okay. Now, what do we do with that numerator? We can rewrite it as y prime equals 1 minus x over the square root of 1 plus x squared over, and the only thing I see I can do here is take out a 2, but I'll just leave it as it is, because taking a 2 out won't do anything for us. And I say we can leave it there. If you want to keep going, then after you beat it with a stick, this will become square root 1 plus x squared minus x over 2 square root 1 plus x squared times 1 plus x squared minus x square root 1 plus x squared. If you get to that, you did it. You're good. Okay, but you don't have to. You can leave it as the one before it. Algebra. Okay. G of x, square root of 1 minus x squared, arc cosine of x. Again, product rule. There's f, there's g. And remember, arc cosine is the same as the inverse cosine of x. So that's what we can change it to. Okay. So f is going to be 1 minus x squared to the 1/2. G is the inverse cosine of x. F prime is 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. Chain rule, chain rule, chain rule all day. Okay, this number times that number. F prime is negative x times 1 minus x squared to the negative 1/2. Let me space this out. G is the inverse cosine of x, g prime is -1 over the square root of 1 minus x squared. Let me just verify that derivative. Moving. Okay. Yes, that's the one we're using right there. -1 over the square root of 1 minus x squared. Okay. Okay, follow your product rule. F prime G. Got a lot of room. That was G of x, so we get G prime x equals -x cosine inverse of x. -x cosine inverse of x of, or times, not of, 1 minus x squared to the -1/2 plus G prime f. -1 minus x squared to the 1/2 over square root 1 minus x squared. Okay, clean up. G prime of x equals -x cosine inverse of x over the square root of 1 minus x squared minus, again, these two. This and this are the same. Cancel. That's just -1. That's it. Yeehaw. You don't recognize me with my hat on phone? Who is blowing up my inbox? Okay, 8, chain rule. So we are going to rewrite this as, remember, arc sine is the same as inverse sine. So I'm going to say inverse sine of sine theta to the 1/2. That's the same. Sine theta to the 1/2. Okay. What is going on there? Oh, he's changing all that stuff. Okay. So chain rule derivative using the inverse sine function. So this means that f prime theta is going to be the derivative of the inside function. So that's a chain within itself. So the derivative of sine theta to the 1/2 is 1/2 sine theta to the -1/2. That's the derivative of the outside, times the derivative of the inside, cosine theta. So all of that's in the numerator, over the square root of 1 minus the inside function, which is sine theta to the 1/2 squared. Okay, cleanup time. You get Let's see. I'm going to keep cosine theta at the top. And then to the bottom, it's going to go with the 2 and the sine theta to the negative 1/2. So you get 2 square root sine theta, 2 square root sine theta times the square root of 1 minus sine theta. Okay, which means that if we keep going, you get cosine theta over 2 times the square root of sine theta times 1 minus sine theta. And nothing else you can do there. If you distribute the sine, you get sine minus sine squared, which could be 1 minus, it's a thought, just a thought. Okay, here goes my thought. Sine theta minus sine squared theta, which is 1 minus cosine squared theta. And yeah, nothing. So nothing. Yeah. Because sine 2 theta is sine squared. It's 2 sine theta cosine theta. And that's, nope. Okay, nope. We're good. That's done. You're welcome. Done, 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 done. Okay. Looking good, looking good. Okay. Here we are going to do the derivative of cotangent. So let me go find that. Cotangent, and we're using both. So we're using the chain and the regular. So negative 1 over 1 plus x squared. Oh, it's like tangent, except it's negative. Okay, perfect. Okay, so before we continue, rewrite this guy as cotangent inverse of x to the negative 1. Cotangent inverse of x to the negative 1. It's going to make our life easier, I think, hopefully. Okay, so we're ready. We say g prime of x equals negative 1 over 1 plus x squared. Negative 1 over 1 plus x squared. Plus, now this one's going to use chain rule because it's the derivative of the inside function. So the derivative of that is, actually, it's not plus. Well, I'll do plus there, but the chain rule derivative is already negative. So there's going to be a negative weighting here, and it's going to be negative 1 x to the negative 2. That's the derivative of the inside function, negative x to the negative 2, over 1 plus x to the negative 1 squared. 1 plus x to the negative 1 squared. Okay. Cleanup time. Yeah, don't forget that little negative there. That comes from the chain rule formula for cotangent. Okay, so clean up. G prime of x equals negative 1 over 1 plus x squared, and now negative, negative. All that becomes positive. That's x to the negative 2 over 1 plus x to the negative 2. All right, so we need to fix this part. So if it's x to the negative 2, we're going to take it in, flip it to the denominator. Flip that to the denominator. Okay. So this means g prime of x equals negative 1 over 1 plus x squared plus 1 over x squared times 1 plus x to the negative 2. Now, distribute this x squared there and there, right? Distribute that. And we get g prime of x equals negative 1 over 1 plus x squared plus 1 over x squared plus 1. And guess what this whole equation becomes, or this whole derivative, all of this just to have a simple answer of 0. Crazy, huh? Crazy, crazy. Okay. 10. Inverse cosine of the inverse sine of t. I hate t, so we're going to use x. Okay. This is going to be the chain rule derivative for the inverse cosine function. So here we go. We're going to have y prime equal to, remember, it's negative, so there's going to be a negative waiting out front already. Negative, and then the derivative of the inverse sine of x. That's 1 over the square root of 1 minus x squared. All of that's in the numerator. Over, this is still cosine, the square root of 1 minus the inverse sine of x squared. So the derivative of the inside function, which is in the numerator, negative 1 over the square root of 1 minus x squared, over the square root of 1 minus the inside function squared. And I'll tell you what, nothing else we can do with this. This becomes negative 1 over the square root of 1 minus x squared times the square root of 1 minus the inverse sine of x squared. At most, you could put the square roots together and have y prime equals negative 1 over the square root of 1 minus x squared times 1 minus inverse sine of x squared. There it is. Ugly, but doesn't get any better than that. And again, just verify if I use the right chain rule for cosine. Yes, negative u prime over the square root of 1 minus u squared. So yeah, so u prime, negative u prime, is all of that, the derivative of the inverse sine. So negative u prime was all of that. That was u prime. Over the square root of 1 minus u squared. Ugly, ugly, I know. Okay, perfect. Another tangent one. The easy ones, okay? All right, so before we begin, rewrite this, make this the inverse tangent of cosine theta. And now we're going to do the chain rule derivative for the inverse tangent function, and we get y prime equals, and it's going to be u prime over 1 plus u squared. So we want the derivative of cosine, negative sine theta, over 1 plus parentheses cosine theta squared. And I get negative sine, my goodness, obey me. Negative sine theta over 1 plus cosine squared theta. Now, could we go further? Possibly, possibly not. We could end there, because cosine squared is the same as 1 minus sine squared, or 1 minus 2 sine squared theta. No, that's cosine 2 theta. So cosine squared, I don't know, worth a try. Maybe not, maybe we're done. Whoops, didn't mean to do that. Maybe we're not done, let's see. Just in thought, that becomes 1 plus 1 minus sine squared theta, which becomes 2 minus sine squared theta, which would do nothing for us. So yes, we are done. That's done. Okay. Next one. All right. Ugly. Okay. Rewrite it. Make this x times the natural log of the inverse tangent of x. So arctangent, same as the inverse tangent. Okay. And product rule. There's f, there's g. F is x. G is the natural log of the inverse tangent of x. Let's do it. I got this one. This one's easy. F prime is 1. G prime. This is going to use the chain rule for the natural log. Remember that d over dx of the natural log of u is u prime over u. Okay. So that means we want the derivative of the inside function, tangent, which is 1 over 1 plus x squared, over the inside function of inverse tangent of x. There it is. Follow your product rule. F prime g. So let me come down here. F prime x equals the natural log of the inverse tangent of x plus, oh, I can rewrite this before moving on. So let's make this look pretty. This just becomes 1 over inverse tangent of x times 1 plus x squared. Okay, and then g prime f, that becomes x over inverse tangent of x times 1 plus x squared. Done. Nothing else to do. It's ugly, and that's why it's ugly. You leave it alone. Cool. What else? Oh, we made it to the last one. Ooh, 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 ooh. Bum, 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 bum. Okay. Sweet. So we are going to have the product rule here on the left side, and that's just going to be chain rule on the right side. So here's F, here's G. Okay. So F is X, G is the inverse sine of X, F prime is 1, G prime is 1 over the square root of 1 minus x squared. Okay, let's take care of this. So here's the first part. Y prime equals F prime G, the inverse sine of X, plus G prime F, X over the square root of 1 minus x squared. So X over the square root of 1 minus x squared. So that takes care of, remember, that only takes care of that part. We still need to take care of the derivative of this part, okay? So circle that and rewrite that as 1 minus x squared to the 1/2. 1 minus x squared to the 1/2. So now let's take the derivative of that using the chain rule, and you'll get plus 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. You're going to be really mad at me for this answer. Y prime equals the inverse sine of x plus x over the square root of 1 minus x squared. Clean this up, negative 2x and 1/2. That gives me negative x over the square root of 1 minus x squared. Well, 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 what do you see? X over the square root of 1 minus x squared minus x over the square root of 1 minus x squared. Gone, gone. And guess what? Y prime is just the inverse sine of x. Terrible, right? But you learn. Okay, oh God. All right, I think that is it. Those are inverse trig derivatives. After this is L'Hopital's, and we're doing limits with derivatives. And L'Hopital's makes limits so much easier. Why couldn't we learn it before? Well, we got to get through stuff first. That is it. I'll send you the notes, send you the video. Enjoy.